Hello everybody and welcome to the University of Queensland's Faculty of Health and Behavioural Sciences Alumni Webinar Series. My name is Paul Purcell and today we'll be joined by Emma Schimke, a PhD student from the School of Health and Rehabilitation Sciences and winner of the 2020 UQ 3-minute thesis competition. Now, for those of you who aren't familiar with the 3-minute thesis, it's a prestigious competition that's held annually to showcase the best up-and-coming researchers at the university and requires competitors to summarise an 80,000-word thesis in just 3 minutes. Today, we're going to let Emma dive a little bit deeper and give her more than 3 minutes as she goes into her presentation on the impacts of sleep and its benefits on memory and word learning. I begin by acknowledging the traditional owners and their custodianship of the various different lands on which we all meet today. On behalf of the university, I pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australian and global society. For those of you joining us live today, you're encouraged to ask questions during the webinar via the Q&A function. For those of you who are new to Zoom, you can find that at the bottom of your screen. We'll endeavour to answer these questions at the conclusion of Emma's presentation. Additionally, this webinar is being recorded and will become accessible via the HaBS Alumni webpage early next week. On this page, you'll also be able to check out all the other great episodes from this series, as well as the upcoming episodes, including next week's episode on multitasking. And now, it gives me great pleasure to introduce Emma Schimke. Sorry, Emma, I'll just jump in. You're just going to have to take yourself on mute, and then I'll let you start again.
There we go. Thank you. I just wanted to say thank you to Paul for inviting me along for this webinar today, and thank you to the audience who've joined us today. And I'm really excited to have a whole 30 minutes to talk about my thesis instead of 3 minutes, like the 3-minute thesis. So, and I'm really interested in any questions you might have through that chat function today. And before I get started, I just wanted to acknowledge my advisory team. So Associate Professor Anthony Anglin and Professor David Copland, and also one of our collaborators, Dr. Shan Gumasol, who's helping with part of the analysis of my PhD. And so why sleep and word learning? So the reason why I'm interested in this topic is because as individuals, we're required to learn words throughout the lifespan. So from when we're an infant all the way through to when we're an older adult. And we might learn these new words in adulthood through studying, maybe at university, maybe when we have a new job, or even if we want to learn a foreign language. And so I'm interested in looking at ways to see how we can boost vocabulary acquisition in healthy adults. But also another thing I'm interested in is how we could potentially enhance treatment approaches in adults with language difficulties. So language difficulties can occur through different methods or pathologies, and one of the most common is through stroke. And this can affect reading, writing, speaking, and listening. And so my hope is that my research can potentially help adults with language difficulties in their speech pathology treatments. And so a little bit about sleep and memory consolidation. So sleep plays a role in memory consolidation through strengthening and integrating new memories. And so there's a model here on the screen in the bottom left, which accounts for this process called the complementary learning systems account. And this is where it's thought that words are initially, or other information, other types of memories are initially acquired in the hippocampus. And after an overnight consolidation period, they're transformed into the neocortical regions of the brain. And so these memories are going from short-term storage into longer-term store. And it's thought that specific aspects of sleep are actually involved in tagging these memories and reactivating them during sleep. It's also thought that sleep can potentially help against interference. So during the day, there's lots of things that could potentially lead to interference with our newly acquired memories. And so sleep may also have a protective benefit for new memories. And so just a little crash course in sleep. So there's many different aspects to sleep. And so with sleep quantity, we can think of it as nocturnal sleep, which is our overnight sleep that we have every day. And then there's also daytime napping, which if any of you are lucky enough to have a daytime nap, that's that shorter sleep that we have throughout the day, maybe if we're a little bit tired or we have that opportunity if we're on a vacation. And with the overnight sleep and the napping, There's also different sleep stages. And so there's a nice diagram down the bottom here on the slide, which shows down here on the x-axis the number of hours of sleep across the night. So here there's about 8 hours of sleep. And then on the y-axis, it's looking at these sleep stages. And so sleep is made up of both non-REM sleep, so that's these stages N1, N2, N3. And they occur a lot more in the earlier stage of the night. And that's where we have our deep sleep. And sometimes it's also known as that slow wave sleep. And you can see here on the diagram that there's, where it's highlighted with the pink there, it's showing earlier in the night that deep sleep is occurring. Whereas there's also REM sleep, which is that lighter sleep, which occurs later in the night. So as we go across the night, we have more of that sleep. And it's when we have our dreaming, and it's a lot lighter in characteristic. And so across the night, there's different sleep cycles, and we usually have a number of these where throughout the night, the deep sleep becomes less and less, and then the REM sleep becomes more frequent as we go throughout the night. And within those certain stages, there's different sleep parameters. So there's that slow wave sleep I just mentioned, which is mainly in that deep sleep. And there's other characteristics such as sleep spindles, which are also thought to help memory consolidation. And it's thought that both the interaction between that deep sleep or slow wave sleep and the REM sleep is responsible for helping us to consolidate the new memories. And so there's many different ways we can actually measure sleep when we're looking at research. So there's a method called actigraphy, which is like this wristwatch on the right here. And so what it is it's like a Fitbit, and you wear it around your wrist, and it actually monitors the degree and occurrence of movement. And so it can give us a nice estimate of how long someone slept for and how many times they may have awoken during the night. The gold standard is called polysomnography, and this is actually where there's electrodes and it monitors brain waves, muscle movements, eye movements. And so that's where someone might be hooked up to these electrodes in an actual sleep lab. Then we can also have sleep diaries where a participant might actually just report their sleep. So they might report the time they went to bed, the time they woke up, and then the number of hours they slept can be calculated. We can also look at alertness measures, and this is important because when we are testing participants at different times of the day, we want to make sure that there are no differences in how alert they are if they're coming in, say, in the morning compared to at nighttime. We can do this through objective measures like reaction time tasks on a laptop computer, or we can also look at subjective measures such as a sleepiness scale where participants are required to indicate how sleepy they might be feeling at that particular moment. We can also look at other types of questionnaires. So this is where participants can self-report their sleep quality over the past month, or even their preference for time of day. So whether they're a night owl or they're much more of a morning person. And so as researchers, we can use just one of these techniques, or we could use a combination. It really depends what our research questions are. And another thing that's important with sleep and memory consolidation is to consider how it might change throughout the lifespan. And so with aging, there's changes that can occur to sleep and to learning. And in particular today, I'm just going to focus on language learning. But with sleep, there's differences to sleep quantity. So throughout the lifespan, there's less of a need for sleep. So sleep duration is shorter as we go across the lifespan. There's also changes in quality. So there's less of that slow wave sleep, which is thought to benefit memory. And there's changes in specific characteristics. So there's reductions in sleep spindles. However, it does seem that the REM sleep, that light sleep, is preserved through older adulthood. And with language learning, so there's changes in our different aspects of language. One thing that stays preserved and actually grows throughout the lifespan is our lexicon size, and that's our mental dictionary. So that's the vocabulary we know. And we know that as we get older, this actually improves and we really expand on this mental dictionary. Whereas working memory actually starts to decline as we age. And then with the retention and retrieval of language, so There's a number of studies that have shown that actually when older adults encode new words, so they learn new words, this remains intact and remains similar to younger adults and how they perform. However, when they go to retrieve those words, it might be the process might be slowed down, or there might be some difficulties in retrieving specific words. And it's a bit like that tip of the tongue phenomena. So where you know what you want to say, but you just can't quite get the word out. So that's a bit more common as we age. And so with these things in mind, then there's potential changes in sleep-dependent memory consolidation. So there's less research at the moment focusing on older adults, but the research is demonstrating that overall, the effect of sleep on learning is reduced in older adulthood, although some tasks it may be preserved for. So when we are researching, we do have to look at each task on a case-by-case basis, and then it's really important to look at performance in both young adults and older adults so that then we can draw these conclusions about these changes in sleep and memory consolidation. And so for my PhD, I was really interested in looking at both young adults and older adults. And in particular, I'm interested in an associative novel word learning task, which I'll explain a little bit more on a different slide. And also looking at whether the effect of sleep changes when semantic information is provided. And so semantic information is providing additional meaning when we're learning new words. And I'll get to that soon when I show you the learning paradigm. And so with two of my main PhD studies, in our first study, we recruited healthy young adults aged 18 to 30 years, and there were 75 who participated. And in study 2, we recruited adults aged 60 to 85 years, and there were 36 that participated. And for each of these separate studies, we had a between group randomized design. So this is where we randomly allocated participants either to a sleep group or to a wake group. And the difference between these two groups was mainly due to the time of day that the sessions occurred and what happened between the sessions. And so participants attended 2 testing sessions. And so this table down the bottom outlines the difference between the sleep and wake group. And so at the first session, which was the learning session, this is where the new words were encoded. And for the sleep group, this happened in the evening, whereas for the wake group, this happened in the morning. And then there was an interval of 12 hours between the first session and the second session, where participants in the sleep group went home to sleep overnight between the sessions, while participants in the wake group stayed awake during the sessions and went about their normal daily routines. So they might have, gone about their normal studying or maybe their normal hobbies or work patterns during the day. And then the participants came back for that final testing session to measure the retention of the new words. And in the sleep group, this actually occurred in the morning the following day, whereas with the wake group, it occurred in the evening the same day. And because there was this difference in testing the groups at the different time of day, we of course then had to look at, factor this in and look at some additional sleep measures, which I'll outline on the next slide here. So we looked at, between the groups, we looked at the participants' sleep quality. So we used a sleep questionnaire where they could indicate what their sleep quality was like for the previous 30 days. And we just wanted to ensure there were no differences between the two groups. We also looked at their time of day preference. So this is where we could look at those night owls versus morning people. We also looked at sleep duration. So we actually did use actigraphy. So that was that wrist monitor. Participants wore it at all times, except when participating in water-based activities. And so it gave us an indication of how long the participants slept overnight in the sleep group, but also in the wake group, it gave us an indication of whether or not they napped. So we were hoping that they wouldn't nap between the sessions. We also at each of the 2 sessions looked at objective alertness. So we had a reaction time task that went for 10 minutes, and then also subjective sleepiness, which is where the participants indicated how sleepy they were. And at the 2 different sessions, so participants were required to learn 20 novel words that were associated with pictures. So it's called an associative learning paradigm. And we were interested in looking at that semantic information. So we had 2 conditions. So On the left here is the learning phase. So participants were required to learn these novel words paired with these novel alien pictures. So participants had never seen these before and they'd never heard their names before. And in the name condition, we had a novel word here at the start. So the example here is snaze. It was then paired with two meaningless proper names. So these were just uncommon English surnames that it was paired with, almost as a control condition. Whereas in our semantic condition, we actually paired a novel word, so here the word is flirks, with two semantic attributes. So these are describing words that added some additional meaning to the nonsense word. And the reason why we use nonsense words instead of, say, foreign vocabulary is because we wanted to make sure participants couldn't look these words up when they went home later. And so participants learnt these words across 5 learning blocks. And then after each learning block, they were tested on their recall. So here on the right, it shows that they actually had to type in the first name, the novel word associated with that alien. And so this repeated 5 times. And our hope was that across the learning blocks, the participants would improve with their learning. We also hoped that there would be no significant differences between the sleep and wake group at this learning session, so that we knew that, I guess, they were matched before then that sleep or wake interval occurred. And so I'll start off with the young adult results. So we did use this same paradigm in both age groups, but I will present the results separately. So at the first session, young adults, they were learning these aliens, and on the x-axis here, there's the number of trials. So they had those 5 learning trials. And you'll notice that there's this nice upwards curve showing that at each time point, they did encode more words when they were tested. And notably, there were no significant differences between the sleep or the wake group, which is great because it means that then 12 hours later, when we retested, if there were differences, we knew it had nothing to do with differences at that first encoding session. And so by the end of the 5th learning block, participants across both groups were able to encode about 85% of those words correctly. And it was the same for both groups. And then there were no differences though for the word conditions. So we didn't notice any differences between whether the words were associated with those semantic attributes or whether they were associated with those meaningless proper names. However, when the participants came back 12 hours later, this is where the results are a little bit more exciting. So we found there was a significant difference between the 2 groups. So the people in the sleep group had actually better retention of the new words across the interval. And there was a difference between that group and the wake group. So here we have the name condition on the left. And in the sleep group, you can see that there's superior recall compared to the wake group. And again, here in the semantic condition, there's superior recall in the sleep group compared to the wake group. So overall, this highlighted that actually sleep did benefit the retention of these novel words compared to staying awake across the interval. And so then we looked at this same design in older adults. And so this was their learning session, so the first session. And again, there were the 5 learning trials. So here you can see that there's improvement across each of these 5 learning blocks, which is what we hoped for. And they were able to remember about approximately up to 60% of the words by that 5th learning block there. And notably, there were no differences between the sleep and wake group again, which is great at this point, and no difference again between the name or semantic conditions. And so when we looked 12 hours later, we tested the participants again. And in this case, with the older adults, there actually were no significant differences between the sleep and wake groups after the delay. So it didn't seem like sleep benefited learning compared to wakefulness. It just seemed like it was equivalent performance. So even though it's slightly higher, the performance in the sleep group compared to the wake group, it wasn't statistically significant. So there were no differences overall. And this is, at the time of my 3-minute thesis, we hadn't quite analysed these results yet. So this was a new finding we had. So we could see that in using the same paradigm, there was a benefit for the younger adults, but no benefit for the older adults. And so overall, what does this mean? So this means that we do have a better understanding of how sleep facilitates vocabulary acquisition. So we have a better understanding of how it can actually benefit this associative type of learning in healthy young adults. And we also have more of an idea of factors that could mediate the influence of sleep on word learning. So we now know that with this particular paradigm, sleep is beneficial for young adults, but it has no benefit for older adults. But we're actually the next stage of my research, which I won't be presenting today, but we're actually going to then look at another type of word learning task. So with this particular task, we're going to look at learning new words through the context of sentences. So for example, when we read a book and we don't know what a particular word is, often we can work it out through the context of the rest of the sentence or paragraph. And so that's the next thing we're going to look at. So we have the data, but we just have to analyze it. And we have both a young, healthy group and an older, healthy group as well to compare. So it'll be interesting to see if the results are similar for that task or whether they're different, given that it does utilize different mechanisms in the brain. And the final thing is that my hope is that these results can actually help in how speech pathology outcomes may be optimized for people with language disorders in the future. So potentially now that we do know that it can benefit younger adults, potentially we can then look at a population who do have acquired language difficulties and see if actually perhaps by having a sleep, perhaps this could help them to consolidate new vocabulary when they do have their language learning treatments. And so that's the end of my talk for today. So thank you very much for listening. And I'm really interested to hear if you have any questions for me today.
Thank you very much, Emma. That was fantastic. We do have a few questions that have popped through, so I'll just go through those now, ask a few of them to you now. For those of you who are still with it, or for those of you who are online and would like to ask a question, as I mentioned at the start, if you use the Q&A section at the bottom, you can put the question through. One of the first questions that's come through is, why did you get into this research topic to start with? What's inspired it?
Yeah, so as a speech pathologist, I'm really interested in language learning and language therapies. And with my advisory team, we've been considering different mechanisms or factors that may influence word learning. And sleep is a really hot topic at the moment. So there's a lot of research looking at sleep, and the more I started reading into it, the more fascinated I became. And it's just something that's so critical to everyday functioning. It's not a luxury, it's something that's so essential. And so, yeah, that's how I came about, I guess, pairing my love of language learning with then the interesting topic of sleep.
Great. We've got a question here saying, and sorry that they've mentioned, sorry if they missed it, but was there a difference between the semantic and name conditions significant for older adults?
Yeah, and I might have skipped over that. So no, there wasn't actually. So although there was a difference in the proportion recalled, that it wasn't statistically significant. So yeah.
Okay, great. And following on from that, if there was a difference between young and older wake groups in the amount of activity, as they're wondering if there was a difference between younger and older wake groups in the amount of activity or potential distracting work tasks that impact retention more.
That's a really interesting question. So at the moment, we've just looked at the actigraphy data for the young healthy group, and we haven't looked at the actigraphy data in the older adult group yet. So we're hoping that might give us an indication around whether there were differences in overnight sleep activity or daytime napping activity. It also might give us an indication of how much physical activity is occurring, whether it's light or moderate. But we also in this design weren't able to track, I guess, what all of their daily activities were. We just did track caffeine intake and exercise that was planned. So we'll have a look at that and see if there's any differences there.
Right. We have another one wondering about the implications of this research for people with developmental language disorder as opposed to acquired.
Yeah, so that's an area actually I'm very interested in. I am a pediatric speech pathologist. So even though my research is looking at adults, I'm very interested in learning across the whole lifespan. And there is some research at the moment to indicate that it occurs differently to, I guess, typically developing children who don't have any developmental language disorder. But at the top of my head, I probably can't say enough about that. But there's definitely a lot of research starting out in that area.
Great. We've got another question asking, I'm also curious on whether this sample had an average good sleep quality or if there'd been any similar research done with people like insomniacs, for example.
Yeah, so we were looking for good sleepers. So part of our screening criteria was to screen out anyone with language disorders. And then we did have the extra sleep questionnaires even after that process. And I think there's differences between insomniacs and healthy sleepers in terms of their memory consolidation. And there's a lot of literature out there around that, but we weren't interested in that for my PhD at this stage. It was just the healthy sleepers.
Great. And with respect to the sample size, what were the demographics of the group that you actually had in for your sample?
Yeah, so we're trying to, I guess, open up to as many people as possible to kind of capture different demographics. So we were able to recruit participants from Brisbane all the way to the Sunshine Coast and also even Byron Bay. And participants had varying years of education. They also had various, I guess, ability to so there were participants who had learnt a second language versus participants who were just monolingual. So we really tried to capture, I guess, lots of different participants through advertising through Facebook, through community groups, through the university, and just using all those different recruitment strategies.
Great, and we've got one more, unless any last ones filter through. And there's been a common theme with these questions, and most people have said, "Well done, Emma, and you've done a wonderful presentation." So
Thank you.
I'll put that forward first. But also, it goes on to ask, do you think that the sample size of your older adult group might have influenced your results with that particular age group?
That's another really interesting question. So, we actually our older adults group, we were hoping to recruit more participants, but we had to stop recruitment early back in March due to COVID. So, and unfortunately, given my PhD timeline, we can't continue with our recruitment there. So it would be, I guess, optimal in the future to be able to do this research with a larger sample size, and particularly then to be able to, draw those comparisons between the two groups, given that they didn't have even sample sizes.
We will squeeze in one last question because I think this one will be quite applicable to the students of the University of Queensland. It asks, do you think that short napping, and given that we noticed it was the difference was most noticeable in the younger group, do you think that short napping would have the same kind of effects for young adult word learning as a full night's sleep?
So there is some research showing that a nap even as short as 6 minutes can actually have some kind of impact on word learning in young adults. Although that research was looking at known word learning. So they were pairing a known word, say dog, with another known word such as lamp. And they had to make these associations. I don't think there's been as much research looking at napping and whether it does have the same benefit. Studies which can give some insight are studies that do occur in sleep labs. So that's where they are monitoring the sleep physiology that occurs overnight. And it's shown that in that overnight sleep period that there is more of that slow wave sleep, which is really critical for word learning. So I'd imagine that overnight sleep could be superior, although I haven't examined this in my PhD.
No, that's fantastic. And that you've answered those questions brilliantly, and the presentation was absolutely fantastic. So, I mean, I know, speaking of learning new words, I've learned a new word which is probably familiar to a lot of people, but I'd never heard hippocampus before. So I've remembered that without having my sleep yet. So that's gone well.
Yeah.
But thank you once again, Emma. It's been an absolutely fascinating presentation. As I mentioned previously, this recording will become available and will be sent out to you via the email address you registered early next week. But on behalf of everyone that's joined, I would like to thank those that have come online today. But more importantly, thank you, Emma, for taking your time to explain this amazing topic to us.
Thank you again for the opportunity, Paul, and thank you to everyone who attended today. And I really enjoyed all the interesting questions that you had.
Thank you very much. Have a great day.
Thank you. Bye.